guys, today we're going to talk about series circuits. The series circuits, how we can know that this circuit is a series? It's an electrical circuit in which current flow in only one path. So the series circuit, it's an electrical circuit in which current flows in only one path. But the most important thing we need to know about the series circuits is to know the properties of the series circuit. And the first important property is the current intensity is constant in the whole circuit. So the total current is equal to the current in R1 and equal to the current passing through resistance 2. But the total potential difference is equal to the sum of the voltages of the resistor connected in series. What did that mean? That means that the potential difference coming from the battery is divided into the number of resistance. So the potential difference for R1 plus the potential difference for R2, if we sum them together, we will get the delta V, the total voltage coming from the battery. And the third thing, that the equivalent resistance is the sum of the resistance in the circuit. So the R equivalent is R equal to R1 plus R2 plus R3 and so on, how much the number of resistance that we have in the circuit. So that will give us that the equivalent resistance is greater than the largest resistance as we sum them every time. So this is everything you need to know about the series circuits. And I want you to be very careful when you're talking about series circuits or parallel circuits. Everything we said in the series circuit, we will say the reversing in the parallel circuits. So, parallel circuits, the electric circuits in which there are many paths for the current. Remember what we say in the series circuit? It's only one path. But here in the parallel, we have many paths. Okay? And what are the properties? Also, everything we will reverse it. If you remember in the series circuit, we say that the current is constant. But here in the parallel, we say it's distributed. And what it means distributed? That means that the current coming from the battery is equal to the current passing through every resistance in the circuit. So I coming from the battery will equal I1 plus I2 plus I3 and so on. And the same thing for the voltage difference. We say in the series circuit that is distributed, but here it will be constant. So what's coming from the battery is equal to the potential difference that R1 have, the same thing for R2, the same thing for third resistance. And here the greater resistance we have, it will have the less current passes through. So again, greater resistance, less current passes through. So equivalent resistance, how we can calculate it? In the series circuit, we only sum all of them. But here we have a law. 1 over R1 plus 1 over R2 plus 1 over R3 and so on. All of them put it in the brackets and the bracket will be to the power of -1. And thus will give you the equivalent resistance is smaller than the smallest resistance. And this is the reverse thing with the series circuits. Problems for the parallel and series circuits. Let's say that in this circuit, what we have a 24 volt from the battery, R1 which is 12 ohm, and R2 which is 24 ohm. The first thing he asked me for, what are the R equivalents? What is the circuits? Is it a series or parallel circuit? Correct. It's a parallel circuit. And how we can calculate the R equivalent if it's parallel? And someone can ask me why it's parallel, because it have too many passes, not only one path for the current. You see this point? The current here distributed or divided. So that means it's a parallel. And in the parallel, we say that R equivalent is equal to 1 over R1 plus 1 over R2 all to power negative 1. So let's see together how we can find it. First, make the brackets. 1 over 12 plus, again, 1 over 24. And don't forget to close the brackets and put it to power negative 1. So what we have? Yeah, it's 8. So here it will be 8 ohm. And for I total, I is the current. And from the triangle, if you remember the triangle of Ohm's law, this is delta V, this is R, and here is I. So to calculate I, it will be delta V over R. We need the I total, so it will be delta V total over R total. So it will be 24 over 8. 24 over 8, what it's equal? It's equal 3 ampere. What about V1? We say before this is a parallel circuit. And the parallel circuit, the voltage is constant, 24 and 24. What about I1? Also, we can get it from the triangle. How we can get it? I1 will equal delta V1 over R1. Delta V1, which is 24, divided by 12. So what you will got? You will got 2 ampere. And I2, it will be 24 divided by 24. So it will be 1 ampere. You get it? Now let's go to find another one, but with a series circuit. You see? You're going to tell me how you know this one is a series circuit. There is only one path for the current to passing through, like you see here. So how we can calculate the R total here? The R total will be 10 plus 20. This is how we can get the R equivalent in the series. So it will be 30 ohm. I total from the triangle, delta V over R. So 90 over 30. So what we got? 3 ampere. I is a constant in a series circuit, if you know that properties very well. So this would be 3 ampere and this one would be 3 ampere. What about the V1? How we can find it? From the triangle, it's I times R. So R1 times I1, so it will be 30 volt, and V2 will be also V2, R2 times I2, so it will be 60 volt. If you sum V2 with the V1, you're gonna get 90 volt, and this is the same voltage of the battery.